Alright, it's time now for the two variable equations with implicit differentiation and word problems. First one we're looking at is a cylindrical water tank. So I'm going to first kind of draw what we're looking at here. Here's our water tank, and it has a leak in the bottom of it. The water tank itself is 30 feet high, and it has a radius of 8. So 30 feet high, radius of 8. Now, things that we know water is exiting at a rate of 5 meters cubed per minute. It's exiting. That means that this should be a negative because it's decreasing here. We also know, we want to say when the water is at 10 feet, we want to know what the, at what rate this water level is dropping. So this is our unknown. At what rate is that dropping? So let's look at an equation to start with of what we should be looking at. Well, volume of a cylinder is going to be pi r squared h. Again, now we have two variables to look at. So, two variables, this pi is just a number out front, so we can stay the same when we do our derivative. dv dt will equal pi times, and then this is going to be product rule. So, first times the derivative of the second. Derivative of h is dh dt. Plus, second times the derivative of the first. 2r, derivative of r, so we need dr dt. Just like that. You can try and simplify it, but at this point, we're just going to start plugging things in that we know. So, we want to look at dv dt. Well, what else do we need? We need to know an r. We need to know a h. We also need to know dh dt and dr dt. Those are all things that are in our formula right there. So, dv dt is how much the volume is changing. Well, we did have a leak. That's why we have that as our negative 5. That's how much the volume is decreasing. The radius is 8 no matter where we are. The height at this time is 10. dh dt, how much is the height changing? That's what we don't know. The radius, how much is the radius changing? So as water level drops, as water is flowing out, does the radius of the cylinder change at all? Actually, no, it doesn't. That's why dr dt in this case is 0. So now let's plug in what we know. We're going to plug in dv dt is negative 5, pi times r squared dh dt. R is 8, dh dt we don't know, so it has to stay as it is, plus h times 2r times dr dt. Well, dr dt is 0, so that whole thing is going to just go to 0. So don't worry about multiplying it out, you know it's going to 0. So, now, to get dh dt by itself, we have to divide by pi and by h squared. So, negative 5 over 64 pi will equal by dh dt. And again, we want units here, so that's going to be negative 5 over 68. dh dt, that's in meters, the height is, and time is in minutes. So, meters per minute. Now, there's a little trick that's going to be a little bit of a shortcut. So, actually, let's go right back to the beginning. Volume equals pi r squared h. If there's anything that will never change throughout the course of the problem of these related rates, then we can actually plug it in immediately. So what I mean by that is, between volume, radius, and height, does anything not change? Well, the volume is obviously going to change when water flows out. So we can't do anything with that. The height is going to drop. The height of the water is going to change as you're going through the course of the problem. However, as you're going down or up in this problem, the radius will never change. So I could actually plug in that radius of 8. I can plug that in immediately. Volume equals pi times 8 squared of height. Or volume equals 64 pi times the height. Now I can do my implicit differentiation. Now I can say dv dt equals, it'll be 64 pi dh dt. Once I've done my derivative, now I can plug in these values. These are values, especially the height is 10 and the dv dt is negative 5, that sort of thing. Those are specific times that we have those. That's not a constant, that's not the same thing no matter where we are in the problem, how high it is. Those are things you can only plug in once we've taken the derivative. So like when the water is 10 feet deep, that means we can't plug that in until later, because obviously the height is going to change. So now we can plug them in at this point. So we can plug in, we still want to know what dH dt is, but dV dt is negative 5 equals 64 pi dH dt. Solve for dH dt, we're going to get that it equals, same thing, negative 5 over 64 pi, unit is meters per minute. And again, take a look. You have the same answer no matter which way you do it. So if you're worried about maybe I'll plug in a number that I shouldn't have, you can always go this route. It's going to look a little uglier at first, but it's going to work out the exact same way. Now, let's look at this problem and see if we can shed any light on this one. Now we're looking at an inverted cone. So here's what our cone is going to look like. Something like this, with our radius. Radius is 2, and the height of the entire thing is 4. So radius of 2, height in 4. Water is going in at a rate of 2 meters cubed per minute. And we want to know how the water level is. So the water's right here, and we're saying the water level in this problem is 3 meters deep. They want to know at what rate. We're going to make our rates here in yellow. So 2 meters cubed per minute. At what rate is this water level rising? That's what we want to know. So again, the water level is something that changes, so we cannot plug it in. Now, volume of a cone is 1/3 pi r squared h. 1/3 pi r squared h is the volume of a cone. If we take a derivative, we would have to do the same thing that we've done before. So dV dt equals, the 1/3 pi will stay out in front, product rule. So r squared dH dt plus second times derivative of the first, so 2hr dr dt. Same thing as before, let's look at the things we know. dV dt, we need to know. We need to know what r is, we need to know what h is. We also need to know each of those, so the dr dt and the dH dt. Let's plug in and see what we can find out. With dV dt, we said we have something going in at 2 meters cubed per minute. The radius, what is the radius at this time? Well, it said when the water level is 3 feet, so we know the height is 3. Now how can I find what the radius is? That's the tricky part here. The radius in this case, we're going to look based on what it was at the full level. When the radius is 2, that meant the height was 4. That meant that the radius is always 1/2 of the height. So the radius is 1/2 of the height. When the height is 3, the radius is 1.5. Okay, let's first look at dH dt because that's what we're trying to find, so that's our unknown. dr dt. Really, I don't know that. It never says how the radius changes. But I just said what the radius was in terms of height. That means I can do an implicit differentiation of this as well. I can say dr dt would equal 1/2 dH dt. It's all related rates. Everything is related. So I could then say down here that it's 1/2 of dH dt. And I can plug all these values in now. So when I plug them in, I'm going to get dV dt is 2, 1/3 times pi, r, the radius is 1.5, I'm going to square it. dH dt is an unknown, we're keeping it as that, plus 2 times the height is 3, the radius is 1.5, dr dt we said is 1/2 dH dt. Next thing we do is just to try to simplify this, which is not very pretty, not very easy to do. So when we do this, we'll end up saying 2 is equal to pi over 3. We're going to have 1.5 squared, which is equal to, I want to make sure I get this right. We're going to turn it into a fraction just because it's going to be easier. Make it 9 over 4. And then plus this whole thing right here. Excuse me. If I did that, this whole thing over here is going to be 2 times 3 is 6. Divided by 2 is 3. Times 1.5 should give me 9 halves. So 9/4 plus 9 halves of dH dt. Simplify even more. So 2 equals pi over 3 times, this will become 18, so 27 over 4 dH dt. 27 over 4 dH dt. So now, try to simplify it more. 2 equals 27 pi over 12 times dH dt. Divide by 27 pi over 12, that means I'm going to have 24 over 27 pi is equal to dH dt, or that would be 8 over 9 pi, and that unit would be h dt. So height per time, the height was in meters, time was in minutes, so meters per minute again. So that looks very cumbersome, very awkward, especially in here. Again, let's see if we can make it a little bit simpler. Same thing in the beginning. Volume equals 1/3 pi r squared h. Well, we did it later on, but you could look right at the beginning. If you know the radius is the same as 1/2 of the height, I can put in that substitution right now. Volume equals 1/3 pi, or radius is 1/2 of height, squared times height. Simplify that. That would be 1/3 pi times h squared over 4 times h. Means volume is 1/12 when I do all the 3 and the 4. So pi over 12 h cubed. Now I can take my derivative from there. dv dt equals, that'll be pi over 4 h squared when I do that derivative times dH dt. And I'm in the same boat where I was before. Plug in what I know. dv dt is still 2. Pi over 4 times the height squared is 3, so this is going to be times 3 squared dH dt. So 2 equals 9 pi over 4 dH dt, which equals, if I multiply the 4 over, divide by 9 pi, I'll have 8 over 9 pi is equal to dH dt. So, 2 different ways, but I get the same answer in each of those 2 ways. So whichever way works better for you, works fine for me. When you have these 2 variable problems, either isolate it before and combine variables before, or go through and do it after. It doesn't matter which way you do it.